So this section is on direct variation. It says here, direct variation is a special type of linear function, so it forms a line. It can be written in the form y equals kx, where k is a non-zero constant called the constant of variation. So if we go back to a couple weeks ago when we were talking about slope, y equals kx, before we would say y equals mx, so k is your m. It is what the slope is. So why they changed it to a k, not really sure, but it's the exact same thing as m. But if you notice, the thing that is missing here is plus your b. So there is no b, there is no y-intercept here. So k is now is the same thing as m as your slope. So you can identify direct variations from equations or from ordered pairs. Also need to say direct variations is the same thing as that constant rate of change. So you may want to add that to your notes. That direct variation is your constant rate of change. So here it says, tell whether 2x plus 4y equals 0 is a direct variation. If so, identify the constant of the variation. Well, the first thing we need to do is we need to make sure that we put this in y equals kx form, or like you were used to saying y equals mx form. So here we've got 2x plus 4y equals 0. So first thing we're going to do is get rid of our 2x. So we're subtracting 2x from each side. So therefore we're left with 4y equals negative 2x. Remember, the 4 and y are being multiplied together, so you need to divide both sides by 4 and reduce that fraction. So y is equal to negative 1/2 x. Because this equation can be written in y equals kx form, it is a direct variation. So that constant variation is negative 1/2. So k is negative 1/2, which means the exact same thing as your slope. Over here, tell whether the relationship is a direct variation. If so, identify the constant variation. Well, here they're giving us a table. We've got our x values, we've got our y values. Now, if you remember back from last week, the week before, when we were talking about slope, you had m is equal to y2 minus y1 over x2 minus x1. So that told your slope. It was your change in your y values over your changes in your x values. Well, that's the same thing that we're going to be looking at here. So if we solve y equals kx for k, we're going to put our changes in y's over top of our x values. So they wrote the fractions down here. So the y value is 1, the x value is 2. So that has a slope of 1/2. Y is 2, x is 4, so 2/4 reduces to 1/2. They're exactly the same direct variation. And the last one, y is 3 over your x value of 6, so 3 over 6, of course, then reduces to 1/2 also. So again, this has direct variation. So now let's go down to our practice problems. It says, tell whether each equation or relationship is a direct variation. If so, identify that constant of variation. So the first problem here, we need to put this in y equals kx form. So again, if you'd like to draw your wall down, draw your wall. Got to get rid of our x's, so subtract x from both sides. Our x's go away. So then we're left with y equals negative x, positive 7, so plus 7. Right there, that's our b. We don't want that. We just want it in y equals kx form. So therefore, this does not have a constant of variation, or does not have direct variation. Thank you. No dv, no direct variation. Okay, next one. Need to solve this guy for y, so again, we've got to get rid of our x's. So we've got to subtract 4x from both sides. So we're left with negative 3y is equal to negative 4x. We're left with a 0. 0 is worth nothing, so we don't need to bring that down. Multiplication here, negative 3 times our y. So to undo it, the opposite, divide both sides by negative 3. Don't forget that negative sign. Cancels. So then we're left with y is equal to, of course, a negative divided by a negative is a positive. So you're left with positive 4/3 x. That has direct variation. It's written in y equals kx form. So yes, it has direct variation. Then the last guy here, negative 8y equals 24x. All we have to do here is just simply divide both sides by negative 8. So we get y is equal to, if you have your calculator, you can type in 24 divided by negative 8, comes out to a nice whole number of 3x. And that has direct variation because it's able to be written, forget our negative sign there, y equals negative 3x. It's able to be written in y equals kx form. So yes, it has direct variation. Then down below with our tables here, we're going to simply write it just like I explained up above with our slope. You put your y value over top of your x value, and then we'll reduce those fractions if they can be reduced. I went ahead and drew an extra line here with a chart here so I can nicely squeeze it in. So y over x, we've got 2 over 4, it's a negative, and then that of course reduces to negative 1/2. Y over x, negative 1 over 2, negative 1/2, and negative 5 over 10, which reduces to negative 1/2. So because each of these have the same direct variation or same slope, there is direct variation. So the answer is yes, it has direct variation. Next one, y over x. So 17.5 over 5. I'm going to have to use my calculator on that guy. So 17.5. I'm going to use my ABC button. Let's see if it will take it. ABC 5. Nope, I get an error because it does not like the decimal with a fraction. So instead, I'm going to have to divide it out. So 17.5 divided by 5, and I get 3.5, which then if you want that as a fraction, you can hit the second button and the PRB button to go from a decimal to a fraction, 3.5. We want that as an improper fraction, so second ABC, so 7 over 2 is that direct variation. So 7 over 2. Y over x, 42 over 12. So 42 ABC 12, 3.5, which again then is the same thing as 7/2 like we just saw. And 28 ABC 8, 3.5, same thing, 7/2. So yes, this has direct variation. And then the last one, 8 over 6. If you need your calculator, 8 ABC 6. Again, you get that mixed number. Second ABC button, you get 4/3. Then 10 over 8. So 10 ABC 8. 1 1/4. Second ABC button, 5/4. So right now you can see that these two fractions are different. So right away, you don't even need to go on. You can say that no, there is no direct variation. But we'll go ahead and fill this in. So 12 over 10 reduces to 6/5. So all of those direct variations were different. So that does not have direct variation in that problem. And that is how you do the first half.